All right. So anyway, like I said, so we learned about synthesis. Are you ready? Yes. Ladies, you ready? Okay. So we learned about synthesis, which is what happens when two or more things form one thing. Then we learned about decomposition, which is unfortunately not called desynthesis, and that's when something breaks into its parts. Today we're going to learn about the third and fourth type. The third type is hydrocarbon combustion. Hydrocarbon combustion occurs when some sort of fuel reacts with oxygen to produce carbon dioxide and water. And that's the great thing about hydrocarbon combustion. It's always the same pattern. It's some kind of fuel, here represented by A, reacting with oxygen to produce carbon dioxide and water. Gesundheit. Today we're going to do a number of hydrocarbon combustions. We're going to combust methane. We're also going to combust a chemical called methanol with oxygen, and that's going to produce CO2 plus H2O. And thirdly, we're going to combust methanol's big brother, ethanol, with oxygen to produce CO2. I'm sorry, what? Oh, ethanol, ethics? Yeah. Well, I will tell you that when you consume a lot of ethanol, your ethics do tend to plunge. Ethanol is grain alcohol. That's the drinking alcohol. There's lots of alcohols, but ethanol will kill you the slowest. So that's when we drink. Yeah. In this case, yes. Hey guys, Dustin asked a really important question. He said, do all of our fuel have carbon and hydrogen? And the answer in this class is yes, because this is a special kind of combustion called a hydrocarbon combustion. And in a hydrocarbon, I know it's going to come as a huge shock, in a hydrocarbon, there's hydrogen and carbon. So, I know, right? So all the combustions we're going to do in this class are going to be hydrocarbon combustions. Now, let me warn you. A hydrocarbon combustion is a very tricky thing to balance, but there are some strategies. Okay? Firstly, the most important strategy is to realize that there's only one molecule of that contains carbon on the reactant side and one molecule that contains carbon on the product side. So this carbon and this carbon have to be the same number of carbon. Okay? And this carbon have to be the same. In a hydrocarbon combustion, there's only one thing that's going to contain carbon. That's going to be our fuel. And there's only going to be one product containing carbon. That's going to be our carbon dioxide. Okay? Make sense so far? The next strategy, which is far more valuable, and again, some of you are not going to do it because you think you're smarter than me, and that's okay. It's just going to cost you points now and then, is to realize that when you have an even number of something on one side and an odd number of something on the other side, your best bet is to make everything even. For instance, O2 is an even oxygen. That's an even oxygen, but that ain't. That's an odd oxygen. So a good strategy is right up front, make that oxygen an even number. You can always reduce. If you find your numbers are too big, you can always reduce. If it's like 2, 4, 4, 4, you can reduce to 1, 2, 2, 2. Okay, you can always reduce later. And you can always erase numbers and replace them with things. But it's a good idea to make things that are even on one side, even on the other side. Cool? All right, let's balance. So take a look. How many carbons here? 1. How many carbons here? 1. How many hydrogens here?
4.
How convenient. How many hydrogens here?
4.
4. How many oxygens here? 2. How many oxygens here?
4.
Good, 4. Because you got 2 here and 2 times 1 is here. So we can easily balance this by replacing this number with a what?
2.
A 2. And you think you're done. Questions, Sergey?
Because I understand it too. It's big.
Excellent. Okay, so there's 2 oxygens coming from the carbon dioxide, and then there's 2 times 1 for the water. This is like if you had H2O, H2O.
2 times X.
2 times X. So let's check our work, because we always check our work because we're smart. 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 2 and 2 is 4 oxygens, and we are balanced. Okay, now the next two are tricky, and they're going to be for you, but once again, strategy. Not important, but strategy. You can look at this and remember that when you see CH3OH, you can think of this as CH4O, even though it's not the chemical. The chemical is CH3OH. And C2H5OH, even though that's not the chemical, you can think of this as C2H6O. It might make balancing a little bit easier. Okay, so you're going to balance now while I watch you. I was going to say why I set stuff up, but pretty much everything is already set up from last class. So go ahead and try to balance these, please. When you think you have a good answer, compare it with your neighbor. Fire stick. This is my fire stick. This is a very important tool. If it wasn't for this, I wouldn't have any hair on my hands. Not that that's a good thing. I just, you know. I'm sorry?
We like to keep ourselves unburned.
Yes. We like to keep our hair, eyebrows, and stuff where they belong.
Eyebrows, who needs them?
When I was at the end of my 8th grade year, Stuart, if you're watching, the end of my 8th grade year, my 8th grade science teacher, who eventually became my graduate teaching assistant supervisor, when I was in grad school, which is hilarious. Anyway, my 8th grade science teacher eventually became my graduate supervisor and became the provost of the science department that I eventually went to. He made a volcano, and it went kapoof, and a big chunk of something or fire or something went up into his beard and singed off like a square inch of his beard. It was awesome. Probably one of these days, yeah. It's only a matter of time.
Would you shave or would you just leave it?
Oh, I'd leave it. It would be a badge. It'd be like, look what I did. This was also the same class where my lab partner knocked over a jar of alcohol and set our entire lab bench on fire. And then, being the quick-witted individual he is, Steve, if you're watching, he took my lab notes out of my binders, like rip, 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 and just like patting out the fire with my lab notes. And I'm like, okay.
Did it work or did it?
Oh, it worked. Yeah, it worked. Yep. He eventually became a chemist too.
How long did that take?
To become a chemist? No, 4 years. University of Oregon.
Oh, I think actually that.
We also don't think sometimes.
Yeah.
They're flammable materials sometimes.
Oh, absolutely. Yeah.
We've all had some fire.
Bro, you just lit the table on fire.
It's a smiling face.
It's a happy fire. Okay, so take another minute. I'm seeing most of you have some good scribbles. If you're having some trouble, that's okay. We'll pick it up here in a minute or two.
I'm lost.
Okay. That's okay to be lost now. Just don't be lost later.
Wait.
All right. So I hear a few people think they might got it.
For the second, not the third.
Okay. So who thinks they might have the second one right?
I know I have it right, Mr. Byers.
Okay. So I saw a hand from Kaylee, Daryl, and
My name is what?
Callie. From Callie. Callie, I think I saw your hand first. So what do you think is the first number here?
2.
A 2? Okay. What do you think is the oxygen's number?
3.
A 3. What's carbon dioxide's number?
2.
A 2. And water's number?
4.
A 4. All right. So let's check our work. Because we always check our work. 2 carbons. 2 carbons. Excellent. How many hydrogens?
7, 8.
8. Because there's 4 here. Times 2 is 8 hydrogens. 4 times 2 is 8 hydrogens. We're looking good so far. And how many oxygens here? 2 and then 6. And 2 by 2 is 4, and 4 by 1, and we got it. Okay. One more left. Yes.
So, for like when it says 2 CO2 and then 4 H2O, do you essentially like add, so you would have 2 O2, which is 4, plus the 4 oxygen, you add them together?
You add them together, yep. Because we care about everything on the reactant side, everything on the product side.
Callie?
Did you know there's microports? Bro, I've adapted to using plastic. I like pure evolution.
All right.
Very cool.
Are you waiting for me to do the last one, or are you doing it?
I already did that one.
Daryl's got it? Okay.
No, you do it. Let me figure this out.
Oh, you're already getting a bonus. You already get to participate in today's lab activities.
But I want to figure this out by myself.
If you get the last one right, yeah.
Okay.
Okay, so Daryl believes that he has the answer to the third one. So what do you got?
Nothing there.
Nothing? Okay.
2.
2.
Over there, 2 CO2.
2 CO2.
And 3 H2O.
And 3 H2O. Okay, let's take a look.
Hey guys, you're checking.
Guys, we're checking Daryl's work to see if he gets to actually participate in today's lab activity. So, 2 C's. 2 C's. Good. 6 hydrogens. 6 hydrogens. Looking good so far. And then 1 oxygen and 4 for a total of 5.
Yes.
And 4 and 7. Boom, boom, boom.
7.
Maybe we should change a number.
Added 2.
I need a 3 in front of the oxygen? All right, let's check it out. So now that we changed the oxygen, we didn't change anything else. So 1 oxygen here and 6 for a total of 7. 2 and 2 is 4 and 3 is 1. Hey, 7. Okay, between Taylor and Daryl, we got it. Okay, so you can come up. Daryl, come on up. And Callie, come on up.
Yay.
Grab some glasses. Let's see, this one is Callie's. Especially those. Okay, Callie, this one's yours. And you get to go first.
These go over glass.
Yes. The big black ones are too. I like the big black ones. Those are whatever works for you.
These are my favorite.
Okay. So take this over here. Now don't aim at the class, but aim it at the wall and fire away.
That's a good one.
You just pull it, you just go boop. Yeah.
Random shoes under.
Okay.
The cap went over there. So that was ethanol. No. It's just a little cap here. And this one's yours. You have the same instructions, just don't aim it at the class. Or me.
I think I accidentally aimed it.
Oh, was my
No?
my finger was probably touching the
Oh.
wire.
Just let it hang. Usually that helps better.
It's not going bang bang.
It isn't going bang bang. Well, sometimes science doesn't go bang bang. Ooh, there it goes.
Stop that! No!
It's on fire.
It is on fire. Bring back yours. We'll use yours.
Never mind. I thought it was gonna fly.
She got a good spark. You didn't get a good spark, so let's try this again.
Are you saying hers is more lit than mine?
Evidently it was.
Say.
Yes. As the cool, it was more lit. Okay.
Why is it turning on and off?
Why is it turning on and off?
You on drugs?
Oh yeah.
I don't know. Yeah, it's probably a trick of the light. Let's aim it that way.
Is it just me?
I think so.
I was loud. I don't know.
Maybe it knows.
There it goes.
That's why does my hand was touching it, so I can feel it like
The electricity?
Yeah.
Yeah, the spark was grounding into you. All right. And Taylor, are you afraid of fire? Okay. So Taylor, grab some glasses. I have a special job for you.
Okay.
And I need someone tall. Oh yeah, Ellie's tall. Ellie, you need to be my camera woman.
Wait, what do you want me to do?
I need you to be the camera woman. So right now the camera's upside down. I need you to basically pull it out of the container and then aim it. We're going to go back in the back. You can take it out, yeah. Just realize the camera is upside down, so you want it to be upside down. Oh no, you don't have to adjust that. You can just hold it. So, just so the whole picture is not upside down.
Okay.
So, yeah, like this. So just hold it like that. And yeah, there's no screen, but you just have to realize we're seeing it. Okay, so you have a very important job. Your job is to keep us from gassing the room out. What's going to happen is I'm going to give you a fire pencil. You might want to move back. Okay, now the fire pencil works like this. There's a little flame.
Yeah.
If you move it too fast, it's going to go out.
Okay.
So in fact, it's probably going to go out quite a bit. So stand right over here. Hold your fire pencil and move it around a little bit so you can see what you need, what you can do. Okay, good. So hold it right up here. And I'm going to make a gas bubble. And your goal is to light the gas bubble before it gets to the ceiling. Let's go a little bit higher so we can let it rise a little bit. There we go. Okay, here we go.
let it hit the ceiling and then light it on fire. Yeah, so then when you go
The tricky part about that is the flame is only so big. Okay. Oh, yeah, there you go. I really want to catch a bubble. Oh, see, you definitely you did right. You did exactly what you were supposed to do.
Okay.
Oh. Maybe if I start the bubble down lower. You're doing great.
Okay.
It's like they say in relationships, it's me, not you. Hey, there we go. Oh, and it stayed on, okay.
Is it gonna like burn our class down?
Nah, I think we're okay. Hey.
Man, you're so good at this.
Quote, I think we're okay.
In like 4 months.
Hey, can we get
No.
Inside the actual.
Hey. One more, here we go. We got 4 in a row, I think.
Taylor. Yeah?
Yeah.
No.
I just like stick it up there. Okay.
Oh, just stick it. No, just stick it.
Okay, thank you. No. No, you guys would be in a world of hurt if we got those guys.
Am I good, dude?
Oh, I still need you to be my camera person.
Oh,
Okay, so that's hydrocarbon combustion. Just go, yes. So that's hydrocarbon combustion. No, you can. You're good. You're great. We're gonna go outside in a little bit.
We're gonna go outside.
Guys, we got one more. So that's hydrocarbon combustion. The third type, or the fourth type of reaction we're going to do is called single replacement. In a single replacement, one thing kicks out something else out of a compound. So you got a compound, and something else comes along and replaces something. So the simplest single replacement reaction, if you like words, there you go. So there's single replacement. The simplest single replacement is when a metal comes along and kicks out another metal. And that's what's going to happen. I'm going to put into the speaker, you can see this is from last period. I'll just set it right over here. I'm going to put into the speaker a solution of silver nitrate. Silver nitrate has the formula AgNO3, and I'm going to write aqueous because that's important. The silver nitrate's aqueous, and I'm going to add to it a copper wire. Oop, there we go. Excellent. Okay, so I just added a copper wire to my silver nitrate. And this is a single replacement reaction, which means the copper is...
Yeah, I hear
No. Relax, Rome. Thank you, though. So, been there. All right. So, guys, it's up there. It's lighter than air. You saw how natural gas is lighter than air. So anyway, so the copper is going to kick out the silver, and what we're going to produce is copper nitrate, which is going to be aqueous, and silver metal, actual silver metal. And you can actually see in the short time I've been talking that the copper wire has gotten a little cloudy. So what's happened is the copper has come out of solution and needs somewhere to go. And where it goes is onto the wire. Those are actually tiny silver crystals that have come out. And you can actually see from last period, look at this. That big, ugly, furry wire, those are all little silver particles that have come out of solution. Yes, you're going to be rich. They're tiny crystals. But hey, you can collect them and maybe make $1. Okay. So if you could do me a favor and balance this very easy reaction, that would be really great. While I write one of my favorites. Nope, it is not. It does need a small change, just a small change. I promised you thermite, and we're gonna do some thermite. We're doing it outside. I can tell you what's going to happen. We'll all be like, I want to go outside.
Okay, is there going to be any gas that I'm going to have to make sure I don't breathe in today?
There might be some smoke.
Okay. Yeah, no, I'm going to have fun trying to not breathe that in. What?
Are you balancing these reactions?
Yes.
Oh yeah. Oh, we were supposed to. Right. I remember you wanted us to do. Okay. Yes.
What's after that 3?
Was AQ, aqueous. So the reason I mentioned that the chemicals are aqueous is in this case it's important. So the silver nitrate is aqueous in solution, and the copper is not. But as the reaction proceeds, some copper goes into solution, becomes aqueous, and the silver comes out. So in other words, the copper has replaced the silver. Now, what I'm mixing, guys. Oh, Dustin, question?
What is like the thing in parentheses under the NO?
Aqueous, AQ. It is AQ. I have weird Q's. I got a Q issue, but I got Q issues.
It sticks with a 4.
Be patient with me. Trust me, it's an AQ. It's an AQ. All right. So what I'm mixing, guys, ladies and gentlemen, what I'm